Welcome back to Rust Coding Challenges. Today, maximum subarray lead code 53. You're given a list of numbers, some positive, some negative, and you have to find the contiguous run with the largest total. The brute force way checks every possible run and is painfully slow, but there's a classic one-pass trick called Kadane's algorithm that finds the answer by walking the list exactly once, carrying just two numbers. Let's build it in Rust. Here's the setup. You've got a row of numbers, positive and negative, and you want the single unbroken stretch that adds up to the most. Contiguous matters, you can't skip around, you pick a start and an end and take everything between. The obvious approach tries every possible start and end and adds each up, but that explodes as the list grows. Kadane's trick is to realize you only ever need to know one thing as you walk, the best run that ends right here. Carry that and the best you've seen anywhere, and one pass is enough. Does cut the whole idea in one picture. Walk left to right and at each number ask a single question. Is it better to extend the run I've been building or to throw it away and start fresh right here? That's the heart of it. Current equals the bigger of two things, the number by itself or the number added onto the run so far. If the run so far went negative, it's dead weight and starting fresh wins. Watch it on this array. We start at -2, add 1. The run so far is worse than just 1, so we restart at 1. -3 drags us to -2, so at 4 we restart. Current is 4. Then -1, 2. 1 keep building. 4, 3, 5, 6. The -5 knocks current down to 1, and the final 4 lifts it to 5. All along, best just remembers the highest current ever reached, and that's 6, the run 4, -1, 2, 1. Look at the current row climbing and resetting, and the best row ratcheting up and never falling. Let's build it. The function takes a vector of numbers and returns one number, the best sum. We seed both trackers with the very first element, best the answer so far, and current the best run ending at where we are. We seed with the first element, not 0, because the answer might be entirely negative and 0 would be a wrong, too optimistic start. The loop is empty for now, and below it a main that runs 3 examples. Let's fill in the loop. And this is the entire algorithm, 2 lines. For every remaining number, we set current to the larger of 2 options, the number on its own, or the number added onto the current run. That single max is the extend or restart decision. Then we update best to the larger of best and current, banking the highest we've ever ended on. That's it. Each element is visited once. We only ever keep 2 integers, and by the end, best holds the largest contiguous sum. We return it. Let's run it on 3 examples. On -2, 1, -3, 4, -1, 2, 1, -5, 4, it prints 6. The run 4, -1, 2, 1, exactly what we traced. On a single one, the answer is just 1. And on all negatives, -3, -1, -2, it correctly returns -1. The least bad single element, which is why we seeded with the first element instead of 0. Every case correct in one pass. Why does it work? At each position, the best run ending there is one of exactly 2 things. This element standing alone, or this element glued onto the best run ending just before it. We take whichever is larger. The moment the running sum would drag us below the current element, that means the past is a liability. So we cut it loose and restart. Meanwhile, best quietly records the highest current we ever reach. One subtle but important detail, we seed with the first element, not 0, so that an array of all negative numbers still returns its largest single value instead of a fake 0. Linear time, constant space, 2 integers. Quick recap. To find the largest contiguous sum, walk once and keep 2 numbers. Current, the best run ending right here, which is the max of the element alone or the element plus current, and best, the highest current you've ever seen. Whenever the running sum turns into dead weight, you restart. It's one pass, linear time, and just 2 integers of memory. Seed with the first element, so all negative arrays, work. That's Kadane's algorithm, and it turns an explosive search into a single clean sweep. A quick note. Breaking these algorithms down in Rust line by line takes real work. If it helps you, the wallets are on screen and there's a Ko-fi link below. Every tip funds the next one. Thank you. That's maximum subarray solved with Kadane's algorithm in a single pass and 2 integers of memory. Once you see the extend or restart idea, a whole family of these problems opens up. Subscribe so you don't miss the next challenge. Tell me in the comments which problem to break down next, and I'll see you there.